Well, today we have another session, amazing session with great speakers. And this one is about AI in entertainment, enabling data scientists to travel from building models to end users, by Nicholas Bartagnoli, Senior Principal Data Scientist at Ben Group, and Tyler Folkman, Head of AI and Product at Ben Group. Nicholas Bartagnoli is a scientist and engineer working to empower creators to create their best content through machine learning. He's spent the last decade applying ML and NLP to solve data problems in medical space, from uncovering novel patterns in cancer genomes to leveraging billions of clinical notes to reduce costs and improve outcomes. Tyler is the head of artificial intelligence at Ben Group. His work explores applications of machine learning in disrupting and transforming the entertainment and marketing industries. Please welcome both. Thank you very much.
Hello? Hello? Oh, perfect. You can hear us. So yeah, I'm Tyler Folkman. This is Nick Bertinoli, and we're here from Ben. What Ben does is influencer marketing and product placement. So if you ever see a beer in a movie that zooms right in on the label, or someone on YouTube or Instagram talking about a product, that's what we do. So we're really trying to get products into natural content. And a lot of what we do is around AI, and we want to make sure that we use data-driven insights to help our brands get into the best content. So we want to talk about how we enable that to be end-to-end data science. So I'm curious, how many people here are data scientists or build machine learning models? So we got a few. Do people run into challenges deploying their models? It's a pretty big issue right now. Like, how do you actually get your models and your AI to your customers in an efficient way? And that's really what we want to talk about, is how we're able to go from the need to the end-to-end process. And the definition of end-to-end data science really is this ability for data scientists to create real organizational value quickly, reliably, and autonomously. People that work in the field often kind of hit this problem where you've got your model, but you don't have a way to get value from it. It's stuck in a research section of your company. Maybe you need a different team to help you get it out there. You don't have an autonomous ability to create value, and that's where data scientists can get stuck, right? And that's where you hear about all this, like, data scientists, we went and hired them, we paid them a lot of money, but they're not really doing much for us because they're stuck. And so end-to-end data science is allowing data scientists to have that autonomous value for their company. And we want to talk about the system we built to enable this. This is a pretty simple diagram of what we've built. But on the left, you've got what we call data creators. So that might be data scientists, data analysts, data engineers, people that want to create value from data. In the middle, you have the system, the platform that enables end-to-end data science, which I'll get into in a minute. And then on the right side, you've got people that want to ingest that data. So maybe you've got a product that wants to have AI insights. The platform can send that over to that product or to that customer. And in the middle, we've got a lot of different things going on where you've got stuff like a real-time transform system, so you can take in real-time requests and send back transformations, whether that's a machine learning model or some other AI. You can do workflow triggering, so you can schedule autonomous learning. So within our system, our models are always updating as new data comes in, getting smarter, getting better. We even have a way to expose applications to our users. So if you're a data scientist and you have an idea, you can actually create an application so users can interact with it and play with your models and understand how it's working. And all this really enables us to do is for data scientists to autonomously and quickly create value and test ideas. And so we want to walk through some of the challenges we ran into and the solutions we came up with on this journey, so you can better understand, if you're trying to be more AI-driven at your companies, what it kind of takes to deliver some of that value.
All right, so I'll step in now. So thank you, Tyler, for kind of talking about the high-level stuff, and maybe we'll dig into a little bit of the details here. So as you saw in that previous diagram, you kind of have your data, the people who manage the data, the people who will consume it. So kind of one of the first problems that we encountered when we started working on this was kind of in scaling internal data systems. So it's how do you work on the communication inside of those data creators and those people who work with the data. So this is like data engineering to data scientists to data analysts. Like, how do we solve kind of the communication problems inside there? And let me just paint a picture for you. You're a data scientist and you create this really fancy model. It does all this good stuff. and then some new data comes in. So what do? Well, you have to retrain your model, you have to look at the data, you retrain it, you put out a new one. Data engineering comes to you and says, oh, hey, we have all of these new people, we need to run these predictions on them. So you go, you manually run it, you do your thing. So there's this kind of like, when you're starting out and you just have like a few data scientists and you're getting spun up on things, it's a really manual process around managing the models. And so the first thing you need to do is really kind of scale this. And there's kind of two important pieces to this. One is a self-serve system to deploy these data transforms and machine learning models, and then an easy-to-use kind of scheduling function to enable frequent learning and modeling and monitoring. And so kind of a recurring theme I think you'll see throughout this talk is that there are all these different people in the process of creating value from data, and not all of them are experts at everyone else's discipline. So data engineers are really good at scaling things and managing the data, and data scientists are maybe really good at building the models, but they're not necessarily good at bridging those gaps. And so what you want to do for at least the data science side is build tools which allow the data scientists to kind of build things that are robust, or build things which are scalable and easy to access. So let's talk a little bit about self-serve deployment of data transforms. So as a data scientist, you're good at building models, but you're maybe not so good at thinking about the cloud architecture necessary to make those models robust and scalable. And so we've built a platform for data scientists to store models, have those models train regularly, and store their featurizations. So one of the kind of big, super valuable things that we found is having a central place where our models live, and having tools around model construction. So a data scientist goes, they build the model, then that model gets stored somewhere that we know. It gets run kind of regularly, and then all of its kind of outputs for the different data that we have are stored in a large feature store, so that you don't have to rerun the model every time. You can kind of leverage that value continuously. So like a data engineer can go and look at what the model has predicted. Data scientists can, instead of grabbing another model and like stacking and having to run it every time, they can just grab the features that have already been trained. So this makes these models accessible to people who otherwise would have to go to the data scientist themselves. And this kind of leads to its own set of problems, which is like, how do you schedule these things, right? When you build a model, it might depend on different types of data, and this data is kind of like, it's related in different ways. And so you need to have an understanding of, for this model, what data is necessary to go into it and what other types of predictions are necessary to go into it. So we kind of built a way of defining this like large computational graph of like, here's this model, it takes this kind of base data, it stores this output as like a feature store, and then other models that rely on that are represented in this graph. So that when we change a higher level model, we know that we also need to retrain the lower level models as well. So it kind of helps us navigate these kind of cascading model interactions. So we also so building these systems to understand how the models are related to each other, and also having the knowledge about how they should be retrained and redeployed is super important. And so with these in place, your data scientists can make models, data engineers can interact with them, data analysts can interact with the outputs of those models, and you can have some more harmony there. But then the next thing is, well, how do you get this out to people who really need it? So like research notebooks don't create value. Like a lot of people work in Jupyter, they build a model, they kind of run it themselves, but your marketing team doesn't know how to run Python. They don't know how to interact with a Jupyter notebook. So we need ways of getting this data out to people. So the example that I kind of like is, when we started off, we would build a lot of these really good models. Our marketing teams would understand that we had these models. They would know that they could come to us to get predictions about views, likes, conversions, whatever. And it would usually come in the form of Slack. They'd Slack us like, oh, here's these 50 people. We need predictions for them, and then we'd have to go kind of run those models or pull it from the feature store or whatever. But what we really want is data scientists to be free to work on building new models and improving the existing ones instead of just answering people's support calls. And so to do that, we worked on building systems to make it easy to deploy custom applications. So giving data scientists this ability to do kind of an end-to-end system, so that they could work on they had a system for a quick and easy back end and a quick and easy front end, and then they can just plug a model into that and spin up these apps so that people can interact with the predictions who aren't industry experts. And then as this kind of developed, it was really important that we also developed a culture of strong software engineering practices, because now the data scientists aren't just making models, they're also making applications that people use. And so it was important to have tooling around ensuring that code quality is really good and that we're following best practices there. So I want to talk a little bit about these kind of custom applications. So a few of you are data scientists. There's a really amazing tool out there called Streamlit, and this allows you to author pretty decent UIs in pure Python. And so what we did was we kind of took this Streamlit system and the Fast API, and we merged them together and made it so that data scientists could create like these little Dockerized applications really, really easily and just plug kind of models into them and define their front ends. And what this let us do is we could experiment quickly with models and our end users. So someone might come to us and say something like, oh, hey, it would be really useful if we had predictions around this thing, or it would be really useful if we had some kind of tool that could help us find like similarity between Instagram users. So that's maybe a good example. And that just comes from one person inside the organization or a few people inside the organization, and we can say, okay, well, let's build an application quickly that kind of meets this need and see how internal adoption is. So we did this with this similarity tool. Some people wanted the ability to plug in an influencer and see who kind of has a similar audience and looks like them, so that we can quickly find other people who might be good candidates to run ads with. And we'd already built a ton of models around this, but there wasn't really an easy way to get that information out to people. And after kind of building this application system, it was very simple for data scientists to try different similarity models, build up a whole app, and then just ship this app to all of our internal users. And people could try it, and kind of we would see which apps more people used, and how much people used it, and then we could invest more time and energy into making that app better and better until it was clear that it was meeting some internal need, and then we could kind of ship that off to our more like app production people to work on it. But this ability to iterate quickly on models and how people interact with those models has been very, very valuable to us. And then as this is happening, now that data, if you're making an application that people need to look at, data scientists aren't usually like software engineers. I mean, sometimes they are, but it's not usually their training background. And so we spent a bunch of time investing in building tooling around ensuring good quality software is being produced. So lots of kind of like pre-commit hooks, examining kind of, is the code written well, is it like type checking, things like that. So building out the tooling around development was also really, really important, because we think that data scientists are maybe not experts in the field, but that's not an excuse for them not writing the best software that they can. And so this helped us reduce the amount of time that code reviews took. And so now that, once you can kind of once you have everybody inside the technical team communicating effectively, once you have the ability to try things externally and let end users try your stuff, the next thing comes, how do you scale this? How do you make these predictions available to everybody? The apps are great, and it's really nice to try stuff and experiment quickly and fail quickly, but where the value comes is once you've identified those kind of key problems or those kind of key solutions, how do you bring that to the most people that you can? And what that comes down to is really creating some kind of programmatic access to your data platform, and also, again, creating kind of systems for your non-experts to author these endpoints. So kind of at each step here, it's really important to have the tooling available for your data scientists to deploy things that they might not be able to do on their own. So like in the previous example, like have them deploy these apps, and then here have them be able to create API endpoints. So as I said, programmatic access to our models is really important. So we've invested a lot of time building out a platform that gives kind of other software engineers that work on our app platform the ability to access all of the all of the model predictions that we have, and also hit our models in kind of like a real-time fashion. And so just creating an API layer for your data science for your models has been very, very valuable, and is kind of a that next step. And then kind of, again, going back to this easy endpoint authoring, you really want your data scientists not to worry about, how should this API be served, how should it be made scalable and reliable, but you want them to be able to just create their models, put them into some kind of place that we understand where they are, and have the rest of that kind of taken care of for them, so they can focus on developing the technology, training the models, instead of all of the infrastructure around that. So I'll pass this back over to Tyler.
Thanks, Nick. So I want to just end talking about the value this created, and if you're to remember kind of anything from the talk, this is probably the part to remember. So why did we do all this, and what value did it create for our company? Well, one is data scientists can now develop, train, and deploy a machine learning application in one day. So you can go from idea to user interface in a single day at Ben. Using machine learning. I've been at companies that takes a year to do. So if it takes you a year to try out every idea you have, you're going to be slow and you're going to get destroyed by the competition in this space. When you can iterate daily on your ideas and get value out to customers every day, you can really move fast and get value, right? So that's a huge one, right? The ability for data scientists to move quickly is what has been enabled. Secondly, we've got multiple state-of-the-art models in production running all the time. They're superhuman performance, so they're beating our human experts at the tasks that they're trained to do. They're retraining themselves all the time. They're releasing their model predictions to a production system, and that's just happening, right? Our production AI platform is taking care of that. Third, the teams are spending time what they're good at. You don't have data scientists taking support requests or writing platform code, or engineers trying to convert data scientist models to production. You have data scientists doing good research and engineers writing good code. And you don't have to have people wasting time on things that don't make sense, which happens at a lot of companies. I'm sure many of you have seen this where, like, why are our data scientists doing this, or why aren't they doing that? Platforms help connect these teams. And then lastly, it allows for collaborative AI. The ability for humans to interact with our models and really make the best actions for Ben. We really believe that human in the loop is very valuable, and humans being able to interact with these models allows us to be successful. So some kind of case studies from this. First is Noom. Is Noom popular in the UK? Have people heard of Noom? It's a diet, weight loss type application. I feel like it's pretty large in the US. For this company, we're able to use our AI and collaborative intelligence to increase their conversions 323% in the first month. So like as we bring in data from our clients, we're able to take that data to learn who's working and not working. So like, should you put your brand with this influencer on YouTube, or maybe this one on Instagram, or on this TV show or this movie, and the AI can start to sort that out for you. We increased their scale by 37% and 3x the number of clicks that they were driving to their website. So whatever company you're working for, you really want to drive people that care about you to your product, right? We can use our AI to do that. And we can really efficiently kind of find ways to do that through our AI platform. Another one is with a brand called Shoots. They create clothing. We were able to exceed their view goal, so the number of people that saw their content through us, by 279%. We beat the average click-through rate on Instagram by 1.5 times, and we had 13.9 thousand clicks. And the best influencer they work with, or the best brand ambassador, was from the AI. The AI was out there looking at influencers and said, this is a good person for this brand. It recommended it to the brand. They liked it. They accepted it. And it was the best performing one. And that's really what we want to drive, right? We want the AI to be looking at the data at scale for our brands and find where they need to be putting their products to get their audience that is really going to engage with them. And then lastly, on the product placement side, when TV shows come out, product placement happens. I'm sure you see this all the time. The BMWs, the cars are very popular, or alcohol, or all these types of products that are in content. We want to be able to predict for the brands how well these content will perform. So what you have here is a new TV show that's kind of been happening week by week, and the red is the AI kind of input. The purple is what actually happened, so how many views this show got week over week. And the blue line is what our AI predicted would happen. So just by knowing the red, the AI predicts the blue line in the middle, where the purple is the right thing. And so very, very early on with these content releases on TV, we're able to give our brands insights into performance. Because on product placement, you have to get into the show before they film it. So you have to have a good idea where to make your bets. You don't want to put your stuff in a show that doesn't perform well or isn't trending. And so our AI can really early on predict that performance for our brands, and so they can get in the best TV shows. One of our brands, even 8 out of 11 shows we work with them on, ended up in Netflix top 10 lists. So this is really powerful to be able to tell your brand story and really get your message out there. And it's driven by AI. It's driven by data-driven, intelligent decisions with our kind of human experts. So that's what we've got. Really, I think the key takeaway from our presentation is data scientists need to move fast. To move fast, you need an end-to-end platform. And when you have those things, you can create value with data science. You won't get stuck in this world where you have a big team of expensive people that don't do anything for you. And I think that's something every company wants. So, any questions?